Hello learners, myself Karesh Pundekar, Assistant Professor in Physics at Ganpat Parsikar College of Education. The title of today's course is Everyday Physics with Demonstration. So we'll be learning physics concepts with the demonstration, and today's topic would be exploring the laws of motion. So let's start. Let's start with the topic exploring the laws of motion. So we'll start with the Newton's law. Speaking about Newton's law, the brief background about it is that Sir Isaac Newton is an English scientist and mathematician famous for the discovery of laws of motion and gravitation. When I say Newton's law, the story must come to your mind that Newton sitting under the apple tree. That is a famous story that Newton was sitting under the apple tree and apple fell down and he discovered the law of gravitation. So we will start with the Newton's three laws. Starting, we will start with Newton's first law. It states that a body in motion remains in motion or body at rest remain at rest unless acted upon by a force. The another name for this Newton's first law is law of inertia. It states that the tendency of object to stay in motion or at rest is also a property of matter that resists the change to its state of rest of motion. So if we take an example, this is a wonderful example I've taken from the picture is from the internet. See, the ball is at rest. It will remain at rest. It won't move unless and until the external force acts on it. Here you can say somebody is kicking the ball. Otherwise, it would have been at a stable point. When somebody kicks it, it changes its motion. So it is moving. The same phenomena occurs now. The object in the motion will stay in motion unless and until external force is applied. Means the ball in motion will remain in motion. So what makes it stop? When goalkeeper try to stop the ball, so it doesn't enter in his goal. So he will apply his force. What he will do? He will stop that ball using his hand. Here, if that player strikes a goal, it will go and it will strike the net. So who is stopping that ball? The net is stopping that ball. So there is an external force. The daily life example we can say, when you travel in a bus, here you can see when bus take a turn or change its motion, what happens? The body is already in the Okay, here you can see the body is in the motion. It is in one motion. When driver takes a turn, it remains in single motion. But because driver takes a turn, it experiences a extra force because the body was in one motion and the driver is applying other side motion because of a turn. The another example would be, suppose I take a glass, I keep a plate something and I keep a coin. The coin will be at rest. We will see this by a demonstration. A coin will be at rest when I give a force, a strong force to the card, whatever I am keeping in between. The coin will be at rest, or that is in the same motion. Once I just flip that card, the coin will go directly inside a cup. We will see that, and most importantly, we see that we are told to use a seat belt. What was the reason? The reason behind is that, see, the driver here is driving. You can see here in the left side, the driver was driving. Suddenly he applies a brake. He or she applies a brake. Because of a belt, she doesn't feels a jerk, or she doesn't just directly strike a window, or doesn't directly strike a dashboard. But when we doesn't use a seat belt, what happens? If there is an accident or a driver is applying a brake, he or she will directly strike a dashboard. So that leads to an injury. So here there is a real life example of where we can use, or we can just give an example of Newton's first law. Next we have Newton's second law. What does Newton's second law say? The net force on an object is equal to the object's mass multiplied by its acceleration. Means what? The equation is force equal to mass into acceleration. The Newton's second law of motion is also known as law of acceleration. Okay, now we know that Newton's first law is about inertia. The object stays in motion or rests unless and until external force acts on it. Newton's second law says force equal to mass into acceleration. What does it say? If you want to accelerate an object, you need a force. Suppose I have a mass, a bigger mass, say 400 kg. I want to make it accelerate, or I just want to move it. The force I require will be definitely more than if I have a mass which is lesser weight, that is 40 kg. You can see in this picture that fellow wants like using his more power to push a mass. Then the real life example would be, suppose you are with a bat and you are with a ball. If you are striking a bat with a tennis ball with the same force, the ball will go to the longer distance than if you hit the bat with the same force to the basketball. It will go to the lesser distance compared to the tennis ball, because here mass of the balls is different. So the force which is applied or force which is going through the ball will be different. Or best example, when you just try to catch a ball, what you do? Ball is in like acceleration, it comes to your hand, and just what you do, you just pull back your hand so that your force the jerk on your hand or the impact should be less and you should not hurt. So what you are doing, you are just reducing the acceleration. Means what? If it is slightly acceleration is reduced, you will feel less force on your hand. So this is about Newton's law. There is another definition we have: the force on a body is proportional to rate of change of linear momentum. Sounds complicated, but the actual definition of the second law is this: the force on a body is proportional to rate of change of linear momentum. So how come this is equal to force into mass into acceleration? Let us see. As the definition says, or the statement says, force is proportional to change in momentum per time. Okay, so what would be the change in momentum? Momentum is mass into velocity. So change in the momentum will be final momentum minus initial momentum. So mv minus mu, where v is a final momentum and mv is a final momentum and mu is a initial momentum, where v is final velocity, u is initial velocity, upon time. Now if we do some mathematics, if we take m out and you get v minus u by t, that is nothing but acceleration. So you have force is proportional to mass into acceleration. If you remove the proportionality sign, I'll take a k. Suppose I take k as 1, that is a constant. It's a constant, yeah, it's a constant. If I take it as 1, we can take that one as, if force is 1 Newton, if you have a force which is 1 Newton, your mass will be 1 kg and acceleration will be 1 meter per second square. So that's how you derive with this statement, the force is proportional to the rate of change of linear momentum, to force equal to mass into acceleration. So now we will see Newton's third law. It's a very kind of like famous law, we say, because most of the people know that Newton's third law is every action there is equal and opposite reaction. Every time we say Newton's third law is this. So it is also called as the law of action and reaction. So taking example of this, we have the beautiful picture here from the Greeks.org. See, here it is nicely demonstrated action and reaction part. Here you can see a gun with a bullet. So there is an action part and there will be a reaction part. When we shoot from the gun, okay, so there will be action part which is accelerating force of the bullet. So what is the purpose? I want to shoot a bullet. So bullet is going in one direction. What would be the reaction? If something is going in one direction, the reaction will be equal and opposite. So in opposite direction, the recoil which we are facing, that is from the gun, that is recoil of the gun, that is action and reaction force. Now we also say one example, okay, Newton's law sometimes doesn't work. If I slap a person, if that person doesn't slap me back, so it is just violates the Newton's third law. But when you have an example here, the fist exert force on a jaw. Somebody is just beating someone. If you are beating someone or if you are just slapping someone, there is a force, which in turn reaction will be what? Here it is jaw exert force on fist. Sometimes the jaw just breaks down. Okay, so there is a force, there is a reaction. So we cannot say that person doesn't slap me back, so there is no reaction. If I just punched a wall, if I punch a wall, okay, a wall won't punch me back, but there is a vibration, there is an energy, there is loss of energy. The wall will take some energy. There is some change in the energy. That is the reaction. And obviously you cannot push a wall with a punch. Then third example would be when we just get down from a boat. You must have experience when you just get down from a boat, just boat goes back. Even when you walk, you are pushing the earth back. So here you can say when you are getting down from the boat, boy's feet exert force on the boat. So you are going in front, but there is a opposite, equal and opposite reaction that you can see when you are just getting down from the boat. Like you are walking, the boat will experience a opposite force. So that is boat exert force on feet. Boat also exert force on feet, but when you just get down, you are just pushing the boat back. Since it's when you walk on earth ground, you cannot push like heavy earth like that. So here boat, since it is in water, it will just experience a force and it will just go back. So here you can say you can see the animation. It just when you just use a cannon, the cannon will face a recoil force when the just that ball goes in front. And best example, we can see the demonstration also. The balloon, the air escaping from the balloon, the force will go in one direction and the ball will go in other direction. There is an action and reaction. So just if we summarize Newton's three laws, a body in motion remains in motion, or body at rest remain at rest unless acted upon by a force. Second law, the net force on an object is equal to the object's mass multiplied by its acceleration. That is force equal to mass into acceleration. Third would be Newton's third law, that is every action there is equal and opposite reaction. So let's see the demonstration, like real life example, how the force works, or how the force exerts, how the laws exerts force. One homework for you, or just a homework, just apply Newton's law to the example of bicycle. You have a bicycle, all three laws can be applied here. Like example, you can just think, there is a steady bicycle, it will remain in the motion unless and until you apply a force on it. So cycle will be at rest unless and until you just go and start riding it. Correct? That is the Newton's first law. How second law would be just connected to this example? Exactly, force equal to mass into acceleration. Okay, you are riding a bicycle. Okay, you are riding a bicycle, you want to accelerate the bicycle, mass into acceleration, you have your own weight, you need some force. Okay, if you are taking somebody, just come with me, we'll go somewhere, he is sitting at back, so you are taking some things or some books at back of the cycle, so you need more force to ride a bicycle. Then third law, every action there is equal and opposite reaction. So when you just pedal the bicycle, you are putting a force in like you are just walking, you are just putting a force in front direction. The tire is moving in front direction, like you are just pushing the ground behind. So there is an action and reaction. Every action there is equal and opposite. So you are going in front, but you are pushing the ground back. So you are going front, but force is at back. So this can be a good example. You can just consider many examples, like where all the three laws can be explained in a single example. So thank you so much for your attention.